Alright, so it's going to be our notes on transformations of linear equations. And this is lesson 3.5 in algebra, so let's add that. 3.5. And this will be something probably really different. I think we looked at it a little bit so far, but not that much. And when we're talking about transformations of linear equations, we're talking about movement of a graph to a new location on the plane. So let me kind of give you an idea of that. So let's just say we use this piece of graph paper here, and we say that we have a coordinate plane, right? We'll just draw it really quick. So we have something like this. Again, this is y, this is x. Okay, and let's say we just have a graph that runs right through the middle. You got to kind of pretend I did a better job of that. But this graph here is actually called the function of x equals x. Okay, that's a really standard graph. They call this the parent function, and that means many other functions then build off of this one. So we're starting these notes with the idea of we're starting with this graph that goes right through the middle of the origin, 0. And what that means is the function of x equals x. But whatever x is, y is also. So if we made the function of x equal 1, then the answer would be 1. So y equals 1. So x is 1, y is 1. If you make x 2, y is 2. And it kind of fits this line that goes right up, equal distance from the x and the y axis, and like splits it in two as it goes this up and as it goes down. Okay, that's a classic function. And that's the parent function of many of the functions we're going to look at. So we might be talking about moving this whole thing up, maybe to here, or maybe we want to move it over to here. The same function, we're going to move it over, maybe move it down, maybe we even flip it the other way. Okay, so that's kind of what we're talking about here. And these have general forms to them, so let's go ahead and look at a few of those. So the first one we're going to learn about is something called a translation. So what these are, for a translation, you can move up, down, right, or left. And that's along that origin axis that we originally started with. This thing, let me show you one more time. So this, if you draw this, should have a ruler here. So this thing right here, this graph. So we can move it this way, like this. We can just move it right on this, coordinate plane over 1. Or we can move it the other way, 2. Or we can move it down, 2 or 3. Or we can move it up. It's the same function, we're just moving it different directions. Okay? Those are called translations. And how you know what they are is if you see a translation that's up, whatever the function is, like we had f of x equals x, we would have f of x equals x plus k. Okay? And when k is greater than 0, that means it's a vertical movement up. So it's vertical. If we then have k less than 0, same kind of thing, this function plus some consonant, and it's less than 0, so we're talking about negative. Okay, this is vertical up, and this is vertical down. Okay, that would be, so if we have this function right here, and we wanted to move it, let's say it had plus 2 over it. It was originally here, right? And would go, plus 2 would actually go vertical up. So it would go 1, 2. Same slope. I don't know if I did that perfect, but it would be up 2. If it was a negative number, it would then be down 2. Same slope, but different location in the coordinate plane. And then right or left is where we have this function, but then we have this, whatever the function is, minus h, and then h is greater than 0. That's going to be to the right. And then, or we might have f of x minus h, and h is less than 0. So this would be horizontal to the right, and this would be horizontal to the left. So this right would be on the positive x-axis, this left would be on the negative x-axis. So when we're looking at these ones, this is the y-axis, and this is the x-axis. That's how we kind of know which direction to move it. Okay, so if we have these different forms, and we'll look at these in class, but kind of get these in your notes, kind of try to understand what I'm talking about here a little bit. And you see some examples here. So this is the up one. This would be the function of x plus k, and if the number is greater than 0, it's going to go up vertically. If it's minus k, I'm sorry, the k is a negative number, so it might be the function of x minus 3 or something, then it would be down. This is the original, moving down to this. So if we keep going, those are translations, up, down, right, left. A couple more examples. Oh wait, let me skip the page here. There's 2. Here's our other example, and we have this is your moving to the right, f of x minus h greater than 0, f of x minus h less than 0. So a positive and a negative. Okay, so and it's going to move this way to the left or this way to the right. Okay, based on whether it's greater than 0 or less than 0. If we look back at these right here. So this h greater than 0, it's going to be to the right. Less than 0, it's going to be on this way. Okay. So we keep going. Another example would be a dilation. Okay. Dilation is a stretch or a compression of a function. So, and what happens when how you know this is true is the function is multiplied by a constant before or after. Okay. So it'd be something like this. So we have g of x. This would be our original f of x actually, and then we would have a times that function before it. Okay. Or if we have with after the function, it would be g of x equals, or the function of g equals f times a times x. So one is on the outside of the function, the other one is actually in the function or after. So this one's done before, this one's done after. If we then look at examples of this, so we'll have a vertical dilation. We would have something, this is where if a, that a we did, so if we go back to these, so so we look at the function a times f of x, and we had that, that's the original one, right? So if we see this one, we know that this is vertical. So we could add that to our notes, right? So vertical is what this is. See that? Vertical. We see this equation, we match it up to this one right here, and we know this is the original function, and it's going to kind of move up and move down this way. Okay? So it's kind of like a spinning. That's what's happening. Okay? And then, and that is if a is greater than 1. Okay? If a is less than 1, but greater than 0, then we have this dilation that goes the other direction. Okay? Like this. But this is that there. So these are talking about vertical. So these would be same equation, right? This would be a times f of x. Okay? And that's where it's on the outside. So if it's less than 1 but greater than 0, we know it's going to be going this way. We know if it's greater than 1, then it would be going up that way. So this is the original. This one then goes up. If this is the original, then this one would be going down. If it's less than 1 and greater than 0. That is a vertical dilation. The other one here, where it's on the inside of the function, you see this? This is going to be a horizontal movement. So on the horizon, on the x, right? So if we look at that, okay. So here, this horizontal, if a is greater than 1, then this one here, f times a times x, we would then have it moving this way, right? Then this one would go the bottom way, the opposite way. But here we're moving on the x, back and forth, right, this way. And then here, same thing, if a is less than 1 but greater than 0, then we're going to have it going this way this time. So we have the original function, it's going to go this way. This one, original function, is going to go the other way. And this, so this is your horizontal movement of a dilation right here, these two. depending on whether that a number is greater than 1 or less than 1 or greater than 0. This one is your vertical movement, so we're talking like this one's going up like this way, this one's going down like this way. And we would know this by the notation of this a, that we're talking about greater than 1 or less than 1 or greater than 0, would be on the outside of the function. And we're going to look at some of these in class. So don't panic too much, just get this into your notes. And then so if we keep going, we have one more to look at. We then have a reflection. Okay? So a reflection is something that flips the graph of a function across a line. This one's maybe not the perfect example to give you, but let me get a marker here to show you. So if we have originally, we have that the function of x equals y, we would have this function right here, right? That's our original. We then flip this about the y-axis, and that would be the same, kind of similar to the dilation. It would be on the outside of the function. When that number is negative, that's going to be a flipping on the x-axis. So we're worried about this. This is where we're flipping it on, this axis. So this becomes flipped, and the new equation is right here. Okay? So it's flipped this way. And then if we keep going, the y-axis flip is going to look like this is our original. And this time, let me grab a different color here. This time we're going to flip it a different way. And because of the one we're using here, it might seem like we're flipping it the same way. That's just because of the nature of the equation. And we'll do some of these in class so you can see them. But here, it really flips the same way because of the nature of the function we used. But we'll see in class. But here we're going this way this time. We're flipping that way. But because it's in the origin like that, it actually flips almost the same way. It seems to. Okay, so that's a reflection. And those are the three transformations we're going to look at. So again, just to review really quick, we have a translation, which is going to be up, down, right, or left. We have a dilation, which is going to be stretching it horizontally or vertically. And then we have, the last one we did there, move it, we have a reflection. Okay? The way we tell these is the notation of the equation. So if we look at these one more time really quick, we would see that this equation for this is f of x plus a number. And then based on where that number is greater than 1, less than 1, and so on, for this one, where you have the plus k, then that would tell us whether it's up or down on the y. And then if we look at this one, let's skip one there. Here's 2. Then we have the other equation, the f of x, this new equation, because really we're using, the other equation we're using is f of x equals y. Or I'm sorry, f of x, the function of x equals x, where y and x are the same number. But here we're going to move them a little bit, and this one's going to be to the right, and that equation is going to tell us the function is x minus h. And in class I'm going to show you exactly how that notation plays out. If I did it now, I think the notes would be a little bit long. So you write this down and we'll talk more about it in class. But then this other one, f of x minus h, is where they're going this way. Okay, one is greater than 1, the other one is less than 1. And we can talk about that in class. And then dilation, we have this new equation. So this is when you stretch it or you compress it of a function on the y or the x. So we originally start with this g of x or f of x equals y. But now we put in a number times that. Okay, so we're going to kind of make it increase its slope. Okay, and in here we're going to decrease the slope. That's kind of something that's really, you can see the change where the slope is much greater because this is a 1 slope right here. For every x, you go up 1. For every rise, you go over 1. You have 1 to 1 run. When you do this, you're going to make the slope greater, so the rise is going to be that much greater than the run. Here, we're going to cut it in half. So here, the rise is going to be less than the run because we're multiplying it by x. That's going to be horizontal movement. It's going to look like this, which might not make a ton of sense. Hopefully, it makes a little bit of sense. We're kind of rotating it up. We're going down the whole thing. Okay, and here This is your horizontal. So vertically we have this function a times the function of x. And it depends on whether a is greater than 1 or less than 1 and a greater than 0. That tells us up or down. Okay, and then horizontal, it is going to be, this function is going to be a times x, okay, on the inside of the function, and that's going to be to the right or to the left. And then finally, one more review. Reflection is going to be flipping it on an axis, so it's right here. We then flip it around the x-axis right here, and that becomes this. So it'll be the negative f of x, and then that's if x, the a is negative, okay, and then here we have where a is less than 0, okay, and that's on the y-axis, and we'll give some examples of these in class, but we have it here, and here we're flipping it on this axis, okay. This one isn't a perfect example. That's kind of the notes. Get these into your notebooks. We'll talk more in class.